Today we're going to talk about lesson 1.6, which is describing pairs of angles. You have a foldable in front of you. This side is the outside. We're going to be talking about obtuse, acute, straight, right, supplementary, complementary angles, linear pairs, congruent angles, adjacent angles, and vertical angles. So if you flip this over, your inside of your foldable should look like this. And we're going to fold just that first column in on each side. Okay. Fold that first column in so that you can see acute and obtuse at the top. Everybody got it folded properly? So you'll be able to see acute, obtuse, right, and straight on the outside. And when you open it up, we're going to talk about the inside. So, first of all, you already told me this. An acute angle measures what? Less than 90 degrees. Okay, so write that down. An acute angle measures less than 90 degrees. Everybody have that written down? You can wave with the scissors if you want to. We can finish cutting them out in a bit. An acute angle measures less than 90 degrees. Then the next one is an obtuse angle, more than 90 degrees and less than 180 degrees. And these are your notes, so if you want to say between 90 and 180 degrees, that's okay too. Okay? An obtuse angle measures more than 90 degrees, but less than 180 degrees. A right angle measures 90 degrees. And a straight angle measures 180 degrees. So in this example, angle JLK is a straight angle. Remind me, how is that formed? 180 degrees is this measurement. And how did we make a straight angle? What did we use? A straight edge, and we drew two rays. And what kind of rays are those called? Opposite rays. Okay? So these are two opposite rays. They form a straight angle, and it measures 180 degrees. Okay? Remember that straight angles were those straight or opposite rays were those rays that went in opposite directions. They had a common vertex, and they formed a line, a straight line. Okay? All right, the next one not yet. Complementary is next. The next one is complementary angles. How many of you have been to a hotel that had a complimentary breakfast? Okay. In the old days, back before hotels really had to compete for your business, that used to be just a bagel or a donut or a piece of fruit, maybe some cereal. Now they're going all out, aren't they? Yeah, they've got waffle irons and they've got sausage and biscuits and gravy and all that stuff, right? But in the old days, I used to think of a complimentary breakfast as being something small. And I'm a farm girl, so when we talked about meals, it's not breakfast, lunch, and dinner. It was breakfast, dinner, and supper. And supper to me, supplementary, was a big meal. Complimentary breakfast, little, supplementary, big. So tell me, what do complementary angles do? They add up to 90 degrees. And supplementary angles, what do? They add up to 180 degrees. So if you don't want to remember my story about complimentary breakfasts and big suppers, you can remember that C comes before S in the alphabet, and 90 is smaller than 180. Both are ways to remember that. Okay? All right, so notice that we have a figure down here that shows you two complementary angles. The first one, we can call it angle D because there's only one angle at that vertex. Angle D has a measure of 52 degrees, and angle H has a measure of 38 degrees. Those two add up to 90 degrees. Okay? Likewise, we have an angle A, or CAB, or BAC, that measures 128 degrees, and an angle FDE, or angle D, that measures 52. Those two are supplementary. They add up to 180 degrees. Don't be confused by the little extra symbol on there. Your book is not going to show you an alpha, beta, omega type of little symbol beside those measures. That's simply because I use a program called GeoGebra to make those images, and it includes a little extra symbol there. Okay? GeoGebra. I think I'm saying that right. It's a strange name. Okay? GeoGebra? GeoGebra. I don't know. Okay, so the next part, we need to talk about congruent angles, and you already know what those are. Tell me what you know about congruent angles. They have equal measures. Yep, their measures are equal. Okay, so congruent angles have equal measures. Now I need you to go diagonal. I misorganized this. Okay, I should have put adjacent angles next. So we're talking about congruent angles right now. Before we go too far, how do we know that two angles are congruent in a drawing? They have a little arc that show on each one, right? That shows that those are equal. So we can't just eyeball it and say, yeah, those look about like they're equal. We have to see that notation on our drawing, on our figures, and we have to put that notation in our figures to show that they are congruent to each other. Okay, so that's what that little arc means in that drawing. So it may not be a bad thing to put an arrow here and just say the arcs mean that they're congruent. That way you're aware of that symbol. Now, I misorganized this. I need to talk about adjacent angles first before we can define this one. So down here in the bottom right, adjacent angles are two angles that share a common side, but they have no common interior points. You bet. Adjacent angles are two angles that share a common side, but have no common interior points. So write that down, please. Adjacent angles, they share a common side, but they have no adjacent angles have a common side, but no common interior points. It allows me to record voice when I'm not away from my laptop microphone, so you'll be able to hear it better. And then I'll upload this to YouTube, and you guys can watch it if you need to rewatch and see. Okay. Okay, so remind me again, adjacent angles are what? Okay. Points. Yep. They have a common side. Have a common side, but no common interior points. Now, what does that mean? That sounds like geometry speak, right? Well, these two are adjacent angles, ZXY and angle YXW are adjacent angles. Do you see that they have a common side between them? What is that common side? Ray XY, good. Ray XY, XY, capital X, capital Y with the ray symbol above, okay? So they have a common side, but no common interior points. Let me draw a pair of non-adjacent angles. That's bad. Try this again. Looks like the same drawing, right? Okay, it's off. I didn't orient it. So it looks the same, right? But A, B, C, and A, B, D are not adjacent angles. Why are A, B, C, and A, B, D not considered adjacent angles? They don't share well, they have a common side, right? Everyone sees that AB is the common side, but it's not within, okay? They actually they have a common side, but notice that C is a common interior point to both of them. ABC has C in it, and ABD also has C inside of it. So that's a common interior point, so these two can't be adjacent. ABC and CBD are, but not ABC and the whole angle, ABD. Okay? So now that we know what an adjacent angle or adjacent angles are, two adjacent angles are a linear pair when their common side are made from opposite rays. So two adjacent angles are a linear pair when their non-common sides are opposite rays. That's the one above adjacent angles. So this is linear pair, and two adjacent angles are a linear pair when their non-common sides are opposite rays. All right, you bet. Two adjacent angles are linear pair when their non-common sides are opposite rays. Turn and teach it to somebody. Okay? The last one is vertical angles. All right, so vertical angles have sides that are two pairs of opposite rays. Vertical angles are angles that have sides that are two pairs of opposite rays. So I'd like you to help me out. We'll make this easier on ourselves, and we'll label these angles so we don't have to write out the three-letter combinations. Let's label these angles. We have RVT. Let's call that angle 1. And let's go clockwise. TVS is angle 2. SVU is angle 3. And UVR is angle 4. Please hand it back. So, can someone give me a pair of vertical angles? I know that Peyton knows. Anybody else know? Laura knows too. Waiting for some more people who know what vertical angles are. Maddie knows as well. No? Brandon knows. Okay. All right, let's see if Ian knows. Ian, can you give me a pair of vertical angles? Which two angles are vertical from each other? 4 and 2. Ian's right. Okay. Angle 4 and angle 2 are vertical angles. Okay. They have two pairs of opposite rays. Okay. And Emmanuel, can you give me the other the other pair of opposite of vertical angles? TU is a ray, right? And RS is a ray or line. So if angles 4 and angle 2 are vertical angles, what's my other pair of vertical angles? Angles 1 and 3. Okay, everybody good? All right. Let's get through this, please. Okay, so I'd like you to name a pair of complementary angles. Name a pair of complementary angles. So remind me, what are complementary angles? Yes, Braxton. They add up to 90 degrees. Do you have a pair for me? Yes, sir. Braxton. GEF is complementary to BAC. Oh, hold on. ABC, good. GEF, always the vertex in the middle, is complementary to ABC. And he could have called this plain old angle angle B because there's a single angle here. But he had to use the three-letter combo with this one. Very good. Because 62 and 28 add up to 90. Okay? All right. Let's look at the next one. How about a pair of supplementary angles? They add up to 180. Okay, Braxton knows. Let's try Jake. HIK and DEG. Does everyone agree? Okay. And he could have just called this angle I, but he had to say angle DEG. Okay? Good job. Here we go. One more term. A pair of adjacent angles. Oh, Peyton knows. Would it be DEF? Would be adjacent to what? DEG. So is angle DEF and angle DEG adjacent? What do you think? Why not? They share G and any interior points over here that we could possibly draw, so almost. Okay. Almost. Let's take DEF out of the picture because that's too large, right? Angle DEG is adjacent to what? Peyton. GEF. Everyone agree? And remember, we could have called it FEG and GED, and that's okay. Okay, does everybody understand adjacent angles? No? Okay. Adjacent angles are two angles that have a common ray, a common side, okay? But they don't have any common interior points. So there's my common side. This is one angle with that common side. Here's another angle with that common side. You see that they have no points in common beyond that common ray? So that's what it means. They're next to each other. They're touching each other, but they don't overlap. Okay? So the reason that we couldn't use DEF is it overlaps with this other stuff. It has the G in between. Okay? All right. Okay, we're going to have to move the seating chart back to where it was. So we're having problems. Next one says, angle 1 is a complement of angle 2. And the measure of angle 1 is 62 degrees. If you want to, you can write it on the back, but that's going to be glued to your, if it's helpful to write it, I don't think so, then absolutely take out a piece of notebook paper so you can take some notes on that. It didn't give you quite enough room. Or you can put this in the complementary one, right? Where it says that these guys are complementary. You can put it with that. This is an example similar to what you'll see on the homework. Okay? So these two are complementary. What does that mean? You only add up to 90, okay? So if angle 1 is 62 degrees, what would be the measure of angle 2? 28, exactly. And it helps you if you show me work on these. So just write 90 minus 62 equals 28. That way if you mess up and you say it's 18, I can give you points so I know it's just an arithmetic error. Does that make sense? Do you like that on the homework? Okay. Next one, angle 3 is a supplement of angle 4. So they add up to 180. Good. 47 minus 180? 180 minus 47. We don't want to have a negative measure, right? So 180 minus 47 is how much? 133. Is everybody okay with these kinds of problems? Okay. I don't want to take a lot of time if you are. Here's one more example. Okay. So this is a leaf from my front yard. It's called a, it does kind of similar to that, but it's actually, I can't think of it off the top of my head. It's a dogwood, okay, a dogwood bush. And so we have a angle 1 here and an angle 2 here. Okay, and they tell us that the measure of angle 1 is 7x plus 13. And the measure of angle 2 is 25x plus 7. Okay? So what are we going to do? Combine the two. Okay? I like that strategy. When we combine the two, tell me what my equation is going to say. Plus 7x plus 13. You could add them up. You could put them below each other. But what should they be equal to? Okay? Good. Why should they be equal to 180? Why are they supplementary? You're right. Straight lines, so what kind of angles are these? What kind of angles are these? They're a linear pair. Very good. Their non-common sides are opposite rays, right? It's a linear pair. They add up to 180. Therefore, if we're solving this, take away the 20. And 32x is 160. So what's x? 5. Are we done? No, awesome. Got to plug it in. Step 1, write the equation. 2, solve it. 3, plug it in. So when we plug it in, let's plug it in the easy way. You could do that. Or you could say, let's do 7 times 5 plus 13. So this is 48. If this is 48, guys, what's the other one? Good. You took the easy way. You said, what's 180 minus 48? And it's 132. Someone else could have plugged it back in. Yes, sir. Okay, so where do we get? That's the supplementary part. Okay? We can do these now, right? Why? You can get your homework back. Okay? All right. We do have homework, but it's going to be a 2-day assignment. Start it tonight. Finish it tomorrow. We're going to have class time tomorrow to work on this. Not super big, no. Okay? I don't think so. I don't remember. Okay? Real quick before we go any further, though, remind me, which ones are linear pairs? 3 and 8 are a linear pair? No, not quite. It was a good try. 8 and 7 is a linear pair. Good. Yep, their non-common sides form opposite rays, right? So 7 and 8, which other ones? 4 and 3, 1 and 2, 5 and 6, 5 and 8, and so forth, right? Which ones are vertical? Four and 2, 5 and 7, 8 and 6, and 1 and 3. Okay. Adjacent would be our linear pairs, right? They have a common side but no common interior points. Vertical angles don't share anything but the vertex. Okay, formed by two pairs of opposite rays. The only thing they share is the vertex. Your assignment, nope, it's coming right here. So your foldable is going to get glued or taped to page 29 of your student journal. Okay? And then we're going to start lesson 1-6 on page 52. 1, 2, 6, and 8. 12. 20 to 42 even. 46, 49. 53 to 59 odd. In your textbook on page 52. Perfect use of your phone. This is an academic use. Take a picture of your assignment. Or write it down in your planner. Okay, give me 1 second.